All right, so again, welcome. This is Tuesday night from 8 to 9, Math 123, and it is February 12th. And so we have, let's see, we have web work number 6 and the Excel descriptive statistics quiz 2 and discussion board 2 is all due tomorrow. And then let's see, project 1 is due on the 23rd, and you want to try and complete your quiz review before you take your exam. That would make sense, right? Make sure when you take your exam, when you go to your exam center, you have a government issued ID, so like a driver's license. Your school ID isn't adequate anymore at the testing centers. So a government issued ID. And then what we want to do is we want to try to get to class before 8 o'clock is ringing, okay? So that I can get my attendance done and we can get rolling at 8 rather than at 5 after, as people are still coming into class. So for those of you who were here before 8 o'clock, thank you. It's very, very helpful. Even if it's a minute or two before 8 o'clock, it's helpful, so we can start class on time. All right, so I don't have the online review, and so what I'll do is I actually loaded a different review. Let me see if I can show you it on our course here. So I loaded a different review, a paper one, just the other day. Let me see. So if you go into module 3 and you look under learning activities, I put an extra review practice exam up there, and I also put the answer key so you can review that and, just extra practice. Sometimes people need extra practice. A different way to look at some of the material. So I made that available for you. And then I have also up here, let's see if I can find it. I have another review that's similar to the paper one that I uploaded for you, and I'll try to do that with each chapter, with each unit. Okay, I'll try to get the other ones up a little bit earlier though for you. So this is just some review questions, that we used a few semesters ago as a review activity. And so what I want to do is just see what questions you have. I'll go through these different types of questions, and you can tell me, what types of questions you have. Okay, so I guess if you don't have specific questions for me, what I want to do is just look at these and go, okay, so are there any questions on, if you look at these types of questions, are there any questions on numbers 1, 2, or 3? As you look at your screen here, we can just work these out together or however you guys want to do it. This is totally your time to ask questions. It's not, I don't want to determine, what we look at today. I want you to tell me what you need. All right. So some of you, I actually muted you because you didn't mute yourself. But, if you talk while we do this, it makes it a little bit better for everybody, I think, rather than everything being in the chat window. So does anybody want to see how we do number 1, 2, or 3? Actually, let me do number 1A just to get us started, okay? So it wants us to write this ratio 12 to 36, and it wants us to put it in the lowest terms. That means we have to reduce them as much as possible. So if you don't know that 12 goes into 36, we can divide those by 2, and we can get 6 over 18. Divide them by 2 again, and we can get 3 over 9. And then divide those by 3, and we get 1/3. So 1/3 would be the lowest term. So we'll make sure that on your exam, you're reducing your answers as far as you can. All right, so take a look at those first 3 questions and see if you have any questions. Okay, so I'm taking that as a no, there aren't any questions on your scientific notation. So remember, let me just show you. This first one here is going to be 5.791 times 10 to the, we're going to count how many spaces we need to move the decimal from here to get between the 5 and the 7, so 367, so 10 to the 7. And let's look at this nanometers one. So nanometers looks like this, and we want to move the decimal again so that it says 7.5. We want that number in front of the times sign, in front of that x, to be between 1 and 10, less than 10, more than 1, or at least 1, times 10 to that. Now when we move the decimal to the right, we subtract 1 every time, so 1, 2, 3, 4, 5, 6, 7, 8. So this would be 10 to the negative 8th power. All right, so the small decimal numbers, those have a negative exponent on that 10, and then the big, large numbers that aren't decimals, those have a positive exponent on them. And when you type these into your exam, don't leave spaces. Don't leave spaces in there, and you might have to write this as 7.5 times 10 negative 8, like that. I'm not sure what the format is. It might have a box for each of these. It might have a box for that, a box for that, and a box for that. I don't remember. And then writing as a percent, all you do is divide those. So you do 7 divided by 8 in that order. And when you do that, you're going to get 0.875. And then it wants you to change it to a percent, so you have to move the decimal 2 places to the right. That's how we would do that. Yeah, don't put any spaces in. And I do need to tell you this. So sometimes when you see your exam score, it might look a little bit lower than you thought it was going to be. You might look at it and go, oh, I had that answer right. Why did it mark it wrong? Anything that's marked wrong, I'm going to look at. Okay, so you've got to give me time to get them graded. All right. I'm not going to grade them until everybody's taken it, because I'm just going to grade them all together. So whenever the last person in the class takes it, that's when they'll get graded. So I will look at those. There are some questions that are going to be open-ended questions, so you're going to have to, I'm going to have to grade those for sure. But there are some that, maybe you typed it in and it didn't like the way you typed it in. Maybe you put a space where there shouldn't have been a space. Now I'll look at those and grade those appropriately. Okay. So don't get too worried. All right, so why don't we take a look at 6, 7, 8, and 9. Take a look at those and see if you have any questions. I'll give you a second to peek at them. All right, so let me take a look. It looks like we're asking questions about number 7. So let's see. Number 7 says there were 123 scooter accidents in the city of Speedway in 2011. The population is 7,200. What is the scooter accident per capita? So accident divided by people. So 123 accidents divided by the number of people. And then let's see. Let me toss that in the calculator. So we're going to do 123 divided by 7,200. And we get, it says rounded to 2 decimal places. So I have 0.01703. So rounding it to 2 decimal places is going to be 0.02. If you change it to a percent, it would be 1.71%. I don't think it asks for the percent though. It's just asking for the accident rate per capita. So 0.02. Okay, any other questions on those? Number 6 through 9. Okay, then let's take a look at the next little group. Number 10 through 12. 10 through 12. So I'll just set number 11. I'll set number 11 up, these three. So it says, what is 15% of 90? So we should set that up like this. This is the is, here's of, and the percent. We would multiply these two together, 15 times 90, and divide by 100. For letter B, it says 210 is of what number? 25%. And that answer is 840. And then letter C, 73. So I'm going to bring this up here. 73 is of 243. What percent? Uh-oh, Kaylee. I don't know why you can't see my screen. It is actively sharing. And Kelly, which did that go with, the 13.5? Was that letter A? All right, yeah, so A is 13.5. That's this one. And did anybody get an answer for letter C? 30.04-ish. All right, those all look good. Let's see, number 12, questions on 12. So notice on number 12, we have part to whole. We have China to the world population. So that one is one that we can write as a percent because it's part to whole. 1.35 billion to 7.1 billion. Since they're both in billions, we don't need to put that part on. And so we can just do 1.35 divided by 7.1, get our answer, 0.1901, and change it to a percent so it's representative. It says what percent of the world population, so 19%. How about take a look at 13, 14, and 15. I'll give you a second to do that and see if we have any questions on that one. All right. So I have a student who's trying to get into class and can't, so I'm going to blank my screen just for a second so I can get the link, okay? All right. Let's see. Okay, so it looks like you guys don't have any questions on those ones. Remember that the child dependency ratio is the under 15 to the middle group, right? And the old age dependency ratio is it's like the 65 and older to the middle group. And then the age dependency is these two groups to the middle group. All right, so this next question is, let's see, it's really division. So questions on 16 or 17. It wants us to find the deer vehicle collisions per licensed driver, and then it wants us to do a ratio. So these, we would take, like Illinois, we'd take 51,627. Let me get my calculator again. So 51,627 divided by 8,373,969. Yeah, we're just going to divide those. And so I got 0.006165. And so we might have a question that says, what is the likelihood of a collision per 100,000? So if we wanted to do the per 100,000, we would just multiply this answer by 100,000 or move the decimal 5 to the right. So we would get 616.5, because that makes a little more sense. There are 616.5 deer vehicle collisions per 100,000 licensed drivers. Because 0.00615 or 0.006165 per driver doesn't make a whole lot of sense. So multiplying it by 100,000, doing it per 100,000 people, gives it some meat, and we can understand. We can wrap our heads around. I know what 616 people look like, right? So 17 says the deer vehicle collision rate for Ohio is the same as North Dakota. If there are 232,000 licensed drivers in North Dakota, how many accidents would there be, collisions? So we have to look at Ohio and say, okay, 67,699 people or collisions, and drivers are 7,963,372. So there's Ohio, and we're going to look at North Dakota. So it says if there are 332,000 licensed drivers in North Dakota, how many accidents would there be? That's how we would set it up. All right. So the next ones we have are the CPI questions. So what do you think of these ones? Any questions on the CPI ones? Again, these are just setting up the ratio, putting the CPI for the year under that year's values, and then finding the missing number. So number 20 is a special question. And so I do want to go over that one because this one wants us to use the CPI factor to determine if minimum wage has kept up with inflation. And so that's a little bit more than just doing the calculation. So we're going to look at this and say, okay, $1.60 per hour. In 1972, the CPI was 41.8. And we want to know, what would the minimum wage be in 2012 if it kept up with inflation? So 2012, 229.594. So it already asks us, or it already tells us the minimum wage, what it actually is. We want to look at this and go, okay, so what if it was keeping up with inflation, how much would it be? So we're going to take that 1.6 times the 229.594, and then we're going to divide that by 41.8. So I got for this one, I got $8.78. So this is the inflation adjusted amount. This is the actual amount. So now that we have that information, we can answer the question. Determine if minimum wage has kept up with inflation. So the way we do that is we compare these and say, well, the minimum wage is $7.25. If it were keeping up with inflation, it would be $8.78. So is it keeping up with inflation? So the simple answer is no, but the quantitative reasoning answer is no, because the actual minimum wage is less than the inflation calculated minimum wage. So remember, we're looking to quantify your answers as you do discussions and take quizzes and your exam. Make sure that you're quantifying. Okay. And I read a lot of your, I hope you guys read my announcements as I post them, because I read, of course, I read all your Excel assignments on the pie chart. And a lot of times the answers that I got on those, when it said, give me two statements you can make about the data. And, some answers I got were, well, this group is a higher percent than that group. Okay, well, that's a very basic comparison. I want you to quantify these comparisons. Like say this one is twice as much, or this one, these two groups together are the same as this other group over here. So do something more than say it's higher, it's lower. Those are really basic comparisons, and we should be doing more than that in our college quantitative reasoning course. So in the future on those, I'm not going to be as easy as I was grading the first round. Okay. So the first round, it was like, okay, did you give me something reasonable that was true? Yes. Okay. I gave you the points. But when we do it on your next ones, like on your descriptive statistic ones, if it asks you for sentences, and on the next ones, if you do a bar chart or a histogram, I'm going to be asking, some questions about the data and making comparisons. Make sure that you're giving me quantitative reasoning answers, not just basic, bigger, smaller. Okay. Yeah, that would be fabulous. I don't know if the 17.4% is correct or not. I'm not, I didn't check, but What did you do? Take 878 minus 725 and then divide by the 878. That would be, if you did that, that would be how your answer is written. So now we would want to take the difference between them and then divide by 878. Okay, so let's look at these. Let's look at these two different methods. Remember, there were two methods of finding weighted averages. Yeah, Kendra, as long as you subtracted them and divided by the 878, that would go with the wording of your answer. Because if you divide by the 725, you get a different percentage. You have to be careful with your wording when you write something like that. Okay, so in the first type of weighted average calculation, we were doing credits times points. Adding those up, and then dividing by the total number of credits. So 8, 12. So we do 33 divided by 12. 33 divided by 12 is going to be probably 2.75. Let's see, 33 divided by 12, 2.75. So the GPA would be 2.75. So that's when we have the items and the costs. A lot of times we would do it with that method. And then with method 2, we're going to take the average times the percent weight. Again, we're going to have to move the decimal. So we're going to take 75 times 0.15. And then write our answer down. And then 70 times 0.20. 80 times 0.20. 82 times 0.45. And then we add all those together. So 11.25 plus 14 plus 16 plus 36.9. So they would have a 78.15% in the course. Notice that the 2.75, the GPA is not a percent. All right. How about questions on 23, 24, or 25? Look at those. All right, so I'm looking at the questions in here, and one of the questions says, what if the median is between six? So if you line your numbers up, let's say you got 8, 10, 12, 16, 16, 18, 19, 20. Three numbers, the middle two are 16. So it doesn't matter if they're the same or not. I guess if they're the same, it's easy because it's just that number, because you want to take the average of the two numbers. So it would just be 16 in this case. If one of the numbers was 16 and one was 18, then the number in between those exactly in the middle is 17. You could get that by adding those up. And what if it was 16 and 17? Then again, we'd add those together and divide by 2, and that would be 16.5. So you take the middle two numbers. If there are an even number of numbers, you take the middle two numbers and divide by 2 after you add them together. If there's an odd number of numbers, it's just the middle number, whatever it is, finding the median. All right, so let me talk to you about the skew. All right, so the skew. So skewed left would be, here's our data. So the tail is on the left. So this would be like age of people having hip surgery or hip replacements. You know, here's age 0, here's age 65, age 80. So, you know, here between the ages 0 and 40, there's not that many people, right? If someone has hip replacement and they're young, it's an abnormality. It's not normal. But most of those hip replacements are all in these age groups. And so that would be skewed left because that outlier down here is pulling the average down. So the average is lower than the median. Skewed right would be the other way. So that's skewed left. Skewed right has the tail on the right side. So this would be maybe it would be number of people, or it would be ages of people playing, I don't know, playing the PBS Kids app on their tablet. Not many older people are playing the PBS app on their, playing the games on the PBS app on their tablet, but kids between the age of 3 and 10, there's probably a whole bunch of them, right? So if someone out here is playing PBS Kids on their tablet, like the Dora game or something, they're an outlier. And so most of the group is down here, clustered together around those age groups. So the tail is on the right, the abnormality is on the right, so that's where the skew is, it's on the right. And then symmetrical would be like this, where the mean and the median are the same. The skewed right, the mean, the average is higher than the median. That outlier is pulling the average to the right. So that's what those would look like. So remember, find the median, you have to order the numbers from least to greatest and then pick the middle number, right? So let's look at this set of data up here. They might all be in order, I'm not sure. It looks like they're in order. So let's find the median. There are 13 numbers, so the 7th number would be the middle one. So the median is 3159. The mean is add all those numbers up and divide by 13. And then I don't know what the skew is. Oh, I don't have an answer key for this. I have to actually do them. So let me do it real quick. 1291 plus 1357 plus 1837 plus 2038, 2427, 2604, 3159, let's see, 3315, 3638, 4233, 4604, 5035, and 10,639. So my guess is that it's going to be skewed right because that 10,000 is so much higher. So let's see, I got 46,177. I'm going to divide that by 13 numbers. And so when I divided, I got a mean of 3552. So remember, it's whichever side the mean is on. So since the mean is higher, so if I were going to put this on a graph, 31.59 is here, 35.52 is here. So the middle number is here, and the average is over here. So that 10,000 way out here is dragging that average. And so that's where the tail is, way out on the right-hand side. So it is skewed right. So yes, Kelsey, it is skewed right. Very good. All right, the last question I have is, it's like a compare and contrast question. Well, okay, let me answer Kelsey's question. So Kelsey's question is, to be symmetrical, does the mean and median have to have exactly the same value? Well, it depends on your data. So they can be relatively close. Like this example was a few hundred off. Well, that's a big difference when the numbers, are as close as they are. So it just depends. I mean, if it was 31.59 and 31.60 with these values, then it would probably be symmetrical. So very, very close to the same, we can say. I don't know. It's kind of a your call answer. If you plot the points, you can tell easier, but it's not. I mean, it's not always easy to plot these heights, I guess. So the last question I have says, compare and contrast the data in the graphs and write a few sentences on your findings. How does each country's age groups compare to one another? And how do these countries compare? How do the countries compare? What can you say about the country's current age dependency? And what about the future? So these ones, we're going to compare them and look at them. So let's look at Afghanistan. Afghanistan has a really, really young, look where most of their population is, right in here. So they have a really high child dependency because the middle group is here's the middle group. So there are many, many more children as a percentage of the population than there are working people. So there's a really high child dependency ratio. There's a really low old age dependency ratio. And then the age dependency ratio, these two together, is pretty high. So in the future, what's going to happen? Well, in the future, these children are going to move up, right? And so they'll have a bigger working class, and it just depends on how many children they have. But so in the future, when these two groups move up, the bigger group here, the children, are going to be able to support the old age because there's fewer people in the old age group. So let's see the United States. So the working group in the US is like this general area, right? And so it looks like it has a good child dependency ratio because there's fewer children than there are in the working class, and there's fewer old age than there are in the working class, and so the dependency ratios are pretty good. The problem is with the US, as we look at this, is since there are fewer children, they're going to have to support this group, right? So that means that the old age dependency ratio is going to be high in the future versus Afghanistan's old age dependency being low in the future. And then Italy, they have a low child dependency ratio. They have a low old age dependency ratio. And then they have the same problem. It's even worse for them in the US because this group is going to be the working group, and this middle group here is going to be the old age group, and they're not going to have enough people to support the old age. So those are just some general statements we can make about them. And it looks like in the US and Italy, people are living longer because there's a lot, percentage of the population the US has a bigger population than Afghanistan, and look how few people percentage-wise they have in their old age group currently compared to the US and Italy. So some comparisons like that. So we're quantifying these things, relating it to information we know about age dependencies. You wouldn't have to necessarily have numbers because we're, in this case, I mean, we don't know what the numbers of people are, and we can't even, I guess we could add up the percentages, but they're hard to tell because they're not all ending up on exactly a line. But you can look at these and say, okay, Afghanistan has a really low old age dependency rate and a really high child dependency ratio. All right, so on your exam, make sure that you explain on the answers that are the open-ended one especially. And again, when you look at your exam and you see your score, remember that there are a few questions that I have to grade still, and then questions that are marked wrong. I will look at all of those and determine if there's any partial credit that will be awarded. And so when you take your exam, the testing center will give you scratch paper to write your work on. Make sure that you, let me see. Make sure that you, on your paper, here's number 1. Put your work there, box it off so I can distinguish between that and the next problem, okay? Don't make your boxes ahead of time though. Do your work, because maybe this box is only this big. And then number 4, maybe that takes a lot of work and it's like this. So make sure you number your work so that as I look at it, because the proctor, whoever's proctoring your exam, they'll send your work to me. So make sure you put your name on there, Jim Jones, whatever your name is, and number your work so that I can easily find it and give you the partial credit, because I'm not going to hunt through your paper. If nothing's numbered and you got stuff over here and stuff over here and it's all a hot mess, I am not going to try and figure out what numbers go with which problem. Okay. I have a lot of exams to grade between all my classes, and I'm not going to spend 10 minutes trying to find your work for number 1. All right, so help yourself out by being clear with your work. Any other questions? We still have a few minutes left, so if you have questions, ask away. So Sharon, what is your question? How many questions are there? That's a great question. I don't remember. I have to look. Okay, so I'm going to pause my screen just for a second and look this up. My view is a little different than yours, and so I have to look. It should tell you, like when you open up your module and you go to the exam, you won't be able to open the exam, but you have a description of it. It says there are 21 questions. All right, and you are allowed to use a scientific calculator, but not a graphing calculator. So there are 21 questions, and they're a hodgepodge of multiple choice, short answer, fill in the blank. The exam review is worth something. So the exam reviews are out of 100 points, and you should get 100 out of 100 on those because you can take them multiple times, right? So you get all the problems right and know what you're doing. And then the 3 exam reviews together represent 5% of your grade. So the 3 exam reviews together represent a half a letter grade, essentially. tomorrow night. The exam review, you should just do it before you complete the exam. I don't think there's a, I mean, the ultimate due date is the 23rd for the exam review. What's due tomorrow is web work 6, the descriptive statistics, and quiz number 2, and discussion board 2. All right, so if you don't have questions and you don't want to listen to your classmates' questions, I'll see you next week. Next week we're going to do section 7. So that's why I'm encouraging you to take your exam this week, because next week we're starting our new material already, and you should already get a jump on it before you come to class. So, look through it, start your assignment before you come to class, so you know what's going on. All right, and I am stopping the recording. Have a great night. I'm going to stick around, though, for a few more minutes for you.